Hello, hello, everybody. In this technology life, we have such a huge opportunity now. We're filming from Multikino now. Dylan has went out of space, and now he's preparing for his show. So I will be a little help for him today. Roy, it's good to have you here. How are you?
I'm very good, very excited. Last talk before the party.
Indeed, indeed. So, are you going to join the party virtually?
Yeah, sure. Just send me an email with all of the beers.
Okay, good. I was just thinking about the cocktails, but okay. So, Roy, could you please help me introduce yourself? And one thing, what the audience will gain from your presentation today?
Well, in this presentation, a little bit about me. I'm a software developer and a consultant, and I'm a big proponent of test-driven development and extreme programming. In this session, we're going to talk about why it's important to adopt extreme programming inside the agile process that we already have in the organization, and why it's actually important that if we don't do it, we're actually going to fail in our agile adoption.
Okay, Roy. So the virtual stage is yours.
Thank you very much. And thank you, everybody, for joining, for everybody. Thank you. Let's get started. For those of you who are joining virtually, just like myself, welcome. For those of you who are sitting in the audience right now, I can't see you, but I'm going to pretend that I can. You should be able to see the slides right on this side of me. Okay, so today we're going to talk about putting extreme programming inside Scrum. Now, if you want, I'm going to share all the slides in a format of a Miro board. So you can see the link of the Miro board up there on the slide on that side. So feel free to join there. And maybe if we have some time, we can even post questions or post-it notes over there. So have fun with that. With that, let's actually get started. A little bit about me and why we're even talking about this today. I wrote a book called Art of Unit Testing, and then a book about elastic leadership. And I have an upcoming book about pipeline-driven organizations. But all of these things are talking about kind of the same thing. It's the same elephant from different perspectives, which is how do we actually drive adoption of the things that we actually care about? How do we drive quality? How do we drive feedback in the organization? So to me, this talk is about the glue, the thing that causes things to actually work. Assuming that we have good leadership practices and that we know how to build in quality, why aren't we actually succeeding in doing that stuff in our own organization? That's kind of what this talk is going to be about. And of course, just like all of my talks, this talk is based on a lot of pain and suffering, tears, sweat, blood, and failure. And hopefully at some point, well, there have been a few successes as well. But I'm here to talk about all the failures, all the reasons that things could fail. They say that you learn a lot from your failures. I've learned a lot. That's all I can say. Hopefully that makes sense. So the world I'm coming from is the world where we're trying to apply continuous delivery, but true continuous delivery, not the BS that we are saying that we're using in our company today, but the thing that we see the Netflixes and the Googles and the Facebooks do. What I want to talk about is the difference between what those companies are actually accomplishing and what we're trying to accomplish in many different companies, and why that's failing, why I think extreme programming is a very important part of that kind of chain of building things together. Because what we usually do, what we usually try to do in our organization is we try to be agile, right? We want to be more agile. We even say that. And a lot of organizations use the word agile to get people into the job. But when you get into the job, you realize the job is very far from agile. It's you wish it was like the posters on the wall, but it's very, very far from that. Jobs might include what we call increment enabling processes, in that they'll adopt Scrum on the left here. But then the expectation is, hey, let's adopt Scrum. let's do automated feedback and pipelines and all that stuff. And if we do both of these things, we're going to be this, or we're going to be as fast, or we're going to be as reactive as these organizations we keep hearing about. And I see a lot of organizations that are trying to implement, the agile processes, and they're even implementing a lot of automated feedback loops. I think that's a big part of succeeding with that. But these are two Lego bricks in a building that we're trying to build here. But still, there is a disconnect. There is a missing piece here, because I see a lot of organizations that both have the agile processes and they both have the feedback loops, but they haven't changed the internal culture and the internal rules to support these things. They haven't implemented engineering practices to support connecting these two things together and actually achieving the fast feedback that we're trying to get. So if we'll take Scrum as an example, Scrum, first appeared in 1986 as a variation of various ideas, and it's based on a rugby term. And in Scrum, most people have seen something that looks like this, right? You have product backlog, you have sprint backlog, Scrum meetings, potentially shippable product. This is kind of the Scrum building blocks. And what Scrum doesn't talk about, if we look further, Scrum doesn't actually talk about what happens inside of these things other than various meetings. Like, this is a bigger example of where Scrum fits in many organizations. You might have a product backlog and a sprint planning meeting, and then sprint backlog. You might have multiple teams working on that stuff. Nothing is talking about those engineering practices here. There's just the assumption that we're doing a good job, but no one is saying, what does it mean to actually do a good job in that regard? If you look further, you see that there are a lot of practices inside Scrum, but none of them are actually talking about what does it mean on a day-to-day basis from the point of view of the engineering practices. And then, of course, you have scalability issues. An organization might come in and say, well, in our scale, we're trying to implement Scrum and we're absolutely failing. Our problem is that we cannot scale Scrum big enough. And that's why we're failing to do, let's say, continuous delivery. So then they go and implement something like SAFe. I mean, look at how scary this stuff is. SAFe, this is just like one portion of what SAFe is trying to accomplish, etc. SAFe inside of it does talk about a lot of different things, and it does say, oh, do XP inside of Scrum. What does SAFe mean by that? Well, a lot of people claim that SAFe it's one of the best marketing ploys that ever existed in the agile space, because they're basically taking all of the good buzzwords and then putting them in the process. So you have SAFe version 4 and version 5 and et cetera, et cetera. And there's like, oh, Kanban is cool. Let's put Kanban in. XP is cool. Let's put XP. Continuous delivery is cool. Let's put that in there. Those things have been added incrementally into SAFe. But what do they actually mean in real life? Organizations implement all of the processes, but they don't actually change how the code is being written. The code is the most important part that an organization can generate in that regard to get feedback, to actually provide a working product. But we're not actually tackling that stuff. It's like we're avoiding it. It's like it's the most complicated in that regard, that we have to change how people work on a day-to-day basis. And so it makes sense that organizations that adopt these things, whether they're good or bad, and I have my own thoughts on whether I like SAFe or Scrum or Kanban, organizations like to adopt the process around people and then basically change names of different things. But they don't actually change the culture or the way that the people actually work on the day-to-day life, because that's much more difficult. If we take the pipeline-driven automation and culture stuff, right, I believe that organizations then would benefit a lot from implementing cooperative pipelines, right? So an organization will add automated pipelines to whatever we just did in terms of the process to get feedback. So these pipelines, these automated pipelines, or people check in code and they get automated feedback, they're very important. But organizations that implement a lot of automated pipelines don't necessarily achieve continuous delivery either. What we're trying to achieve is a combination of multiple things, a combination of the pipeline-driven organization on one side, which is the internal infrastructure of getting feedback in multiple levels, and basically the ability to teach those pipelines how to make tactical decisions instead of people. So removing people from the automated equations, such as deciding if a build is actually passable, if we can increment the version, if the build is releasable, etc. These things should be determined by pipelines. On the other side, we'll have increment enabling processes, either Kanban or Scrum or a lot of different things. But the XP practices or the engineering practices play the glue that binds these things together. Because if we cannot expect people to work in 1 week sprints or 2 week sprints or even Kanban continuous, where every commit goes to delivery, if the people working do not have the proper engineering practices in place. So XP is one of the first ways that I got introduced to these engineering practices. And of course, the father of XP, Kent Beck. Everybody here probably knows who Kent is. I got introduced to extreme programming from the book Extreme Programming Explained. This is the book. I'll explain a bit more later. But I really loved the values that the book was talking about: simplicity, feedback, respect, courage, and communication. I even put them on a business card that I had when I was just starting to be a consultant, because I really think that the what do you call it? The courage part is really, really important. The feedback we get from the pipelines, respect and courage and communication is a people structure thing. Simplicity and is part of the engineering practices as well. So there's a lot of stuff that I really connected to, but these are just words. What does it actually mean in real life? Well, extreme programming on the outside, it kind of seems like stuff that you've heard before, although it came before the stuff that you already know. Like extreme programming, I knew about XP before Scrum, I think even existed, right? So a lot of the things are going to seem familiar, and then you'll realize that Scrum and Safe and a lot of different methodologies that exist today, or processes or frameworks, I don't even know what to call them anymore. Every time I call something, everyone says, oh, you should call it a different thing. Well, whatever those things are. A lot of them are combinations of different things taken from other methodologies or processes. So XP talks about iterative planning and project heartbeats and planning. It talks about testing, planning, design, coding, and software increments too. That should sound familiar. But it also talks about what happens on the day-to-day life of people when they actually implement the code. It talks about simple design CRC cards. So a lot of the ideas about user stories come from some of these things: spike solutions, prototypes, refactoring, pair programming. These are things that I heard about the first time from extreme programming, unit testing and test-driven development, acceptance testing. A lot of these things, you'll find people trying to accomplish them in various things, or at least saying that they're trying to do it. But I want to introduce the original OG of this, because I think if we put XP as an example of a target, then we have something to ascribe to. We have a set of practices that we can kind of measure whether we're doing them or not, and we can use them as a guidance inside our own internal processes. So it doesn't matter if you use Scrum or Safe or Kanban. You can still do a lot of these engineering practices regardless, because it's about how you actually create the code. What is the process? Just like debugging is an example of how you create the code. Doesn't matter what process you work. Debugging is built into whatever it is that you do. You don't ask for permission to do it, just the way that you work. Now, if you look at the site xprogramming.com and you look at the basic idea, you can see that extreme programming is made up of a lot of different things that seem familiar. Architectural spikes, system metaphors is an example of using vocabulary that everyone agrees on. Spikes, release planning, user stories, test scenarios going to acceptance tests, goes into an iteration. So what might be new here? Well, maybe the spikes is relatively new for people that have already seen basic Scrum stuff. As you jump into the iteration part, you will see that inside an iteration, there's a lot of stuff that people will find familiar. We have a latest version, we have iteration plan, learn and communicate. That stuff is not really changed in terms of what to expect. The big change comes inside the development. And this is where XP differs from a lot of other methodologies, why I really like it. It's very pragmatic. It's one of the only kind of processes or methodologies that talks about how development actually happens. And it gives us a lot of different guidances. For example, not only do we have stand-up meetings, right? Stand-up meetings should be familiar for a lot of people, but it talks about pair programming, refactoring, CRC cards, test-driven development, unit testing. All these things are actually part of the way that you expect it to work. Collective code ownership means that everyone can have ownership of the code. People do not own a specific piece of code, but they're allowed to have multiple pieces of domain knowledge inside the team. So for example, a mobile person might work on the back end. If you're working on a specific component, you can teach other people how to work on that back end, front end, it's kind of imagine a feature team the way that we talk about it today. That's where this is supposed to go eventually. There are a lot of ways to dissect this, but I'm kind of giving some ideas of how to start thinking about it. So the XP practices, if you look at them in a radar chart, almost, you have the things that are outside the customer tests, whole team. So this is where maybe Cucumber can play a part. Then we have the coding stuff, continuous integration, and then we have internal solo stuff. You can do pair programming with another person, you can do test-driven development, refactoring. These things are the team level. These things are team-facing level, where they face with other teams or other stakeholders, etc. So these are some of the XP practices, and I try to put them in like these three different categories. You'll have developer-related stuff, you'll have customer-related stuff, and you have code-related stuff. And so when developers are working with their internal or outside customers, these are the practices that are related specifically to those two things. When developers are interacting with code, then these practices are related to these two things. When the customer is using our code, we're talking about small releases. And I've highlighted in white the practices I'm going to talk about today. And you can see that the planning and continuous testing, continuous integration are kind of all over the place. They touch all of the areas. And you'll see a lot of these things where a lot of methodologies are talking about them. It's these things that when we're talking about engineering practices, these are a lot of things that we're missing. So that's where my focus is. That's where I think a lot of organizations need to adopt new skills. So let's jump into them really, really quickly. Testing and test-driven development. Yeah, I've been a fan of that stuff for a long time. And where I picked that up is from extreme programming. That's where I learned about this stuff. There's a book called Test-Driven TDD Explained, or Test-Driven Development TDD by Example by Kent Beck as well. And I really liked it. It's a very pragmatic way to develop software. Testing and TDD, think of them like micro iterations that take minutes, maybe an hour if it's the first test of something really, really complicated. When you finish that test and it's green and you can actually commit code. So when you have small tests, you can actually have small commits, and small commits that are green and all the tests are passing means that you have a small piece of technically releasable software. So at its core, what I like about testing and TDD is that instead of thinking in weekly iterations or bi-weekly iterations, I'm thinking in micro iterations of minutes, where technically each commit can go into the main branch and delivered to the customer, because I know that I didn't break anything and I can incrementally add more features. So customers, or well, in our case, I'm a consultant, I'll call them customers, but organizations that adopt TDD allow themselves to do continuous delivery, because continuous delivery requires that you always have a deliverable product. Now, if you're planning to have a deliverable product only after a specific testing period is passed, maybe every week or every couple of weeks, then technically you do not have continuous delivery. So when we are trying to get to very, very small steps, when we're asking, what is the thing that is causing, what is the oil that runs the machine? It's unit testing and TDD are very powerful oil to put in that machine because it allows us to run really, really fast with confidence. If we don't have confidence, we don't run, we walk, we might even crawl. Refactoring is another example of that oil that oils the machine. Without refactoring, then our code is actually harder to change and harder to deliver, and we create more technical debt. Technical debt slows down the machine. So continuous refactoring is a huge part of engineering practices that we want people to learn. Same thing as pair programming. I see all these big organizations claiming, oh, we do knowledge sharing and all these things. Pair programming is the ultimate example of knowledge sharing, where you have people sitting and talking with each other. You don't always have to do it, but I would highly recommend that you do it as much as you can, because it actually helps collective ownership, which is the next thing. If you want people to be able to work on other people's code, pair programming is a great way to achieve that. Now, why is collective ownership important? Well, at first, when I was looking at it, it was like, oh, yeah, it kind of makes sense. But here's where collective ownership is another piece of the oil that runs the machine. In larger organizations, it's not just one team delivering the product, it's multiple teams. And a lot of times, those teams have dependencies between them, or even internally inside the team, you'll have people that are bottlenecks because they know a specific thing. And so what happens is that people wait for other people to do something because they cannot work on that piece of code. And so when you don't have collective code ownership, you basically have a bunch of bottlenecks, a bunch of dependencies between teams or between people inside teams, and that slows down the machine. So when we're talking about companies that can deliver fast, it means that most people can work on most of the code. And you want to minimize the effect of dependencies between people and their pieces of knowledge. Pair programming is a good way to achieve that. If we're trying to achieve feature teams, that's another good way to. A feature team is an example of something that can help increase collective code ownership. And finally, continuous integration. When we're talking about feedback, continuous integration, first time I heard about it was in extreme programming. And then there were books about it and all that stuff. And that's pretty cool. Today, we're also talking about continuous delivery. But initially, there was continuous integration, which is the idea of getting feedback on your code. A lot of companies are trying to achieve continuous integration. And the problem with it is that it doesn't just need a pipeline. Anyone can create a pipeline. I've seen companies with hundreds of pipelines just running around, but nobody's looking at the pipelines. Nobody's checking in the code continuously into the branch. The pipeline is only running on specific environments and not on the continuous environment. So just the fact that we have a pipeline doesn't mean that we actually get to use it. If we combine those things together, we end up with getting feedback on our refactoring and our test-driven development. We work together to actually learn about each other's code when we're doing pair programming. The integration is just another form of feedback. So all those things are kind of the basic idea of where we want to go. And of course, that all sounds probably very nice and cool. And up until now, this is where the honeymoon phase is. Companies might even invite me and say, oh, okay, we want to do engineering practices, do training on TDD, or teach us refactoring, or let's talk about pipelines, or etc. Now let's talk about the glue that causes that stuff to actually happen. If we all agree that engineering practices are important, and that's the glue that you need to get your organization towards continuous delivery, why aren't we doing it today? I mean, most organizations already talk about achieving, doing engineering practices and all that stuff, but they're not actually doing it. And of course, the answer is very, very simple. I think everyone agrees with that. Nobody has time to do that stuff. Everyone agrees, yes, XP is so cool and so amazing and sure, and unit testing and TDD and whatever. However, we have this really, really important deadline right now. So we're going to talk about it maybe later, but for now, just get back to work. How's that? Okay. So that's kind of where people get stuck, because there's a difference between knowing what the right thing is and actually doing it. So first of all, we talked about what is the right thing. What is an example of the right thing? Now I'm going to talk about how do we actually achieve some of that right thing. So that's the second half of this. Because most organizations are what I would call in survival mode or survival addiction. Survival mode is an example where a team or maybe a whole group of people is stuck, overcommitted, over deadline, over promising things, and they're already late fixing the things that they were late on, and there are things coming in, and so they don't have time to learn any new skills. They don't have time to learn how to actually achieve those engineering practices because they're too busy fixing fires. And if I was in that team, I wouldn't learn anything either because I was too busy fixing fires. Many organizations are very comfortable working in survival mode. And when I say comfortable, I don't mean that they're not bitching about it and saying, oh, this sucks, but they're used to it. And they know how to work in that paradigm. They know how to get the few people to work on the 2 a.m. crashing build. They know how to handle when you have multiple people screaming at you, right? So, so it's an anti-pattern, but it's very easy to stay in it. So how do you get out of that so that you can actually teach people those new skills? That's where, there's a book that talks about that stuff. It's called Elastic Leadership. There's this guy who wrote it. I think his name is Roy Osherove or something. I'll give a link to it. And in that book, I talk about the fact that our teams are in survival mode, and we want them to be in learning mode so that they can actually learn all these cool things. And moving from survival to learning mode is not easy. It requires a lot of leadership courage. And we're getting back to the idea of courage. Also, our leadership tactics in survival mode are very different than in learning mode or self-organizing, which is where we want to be in agile teams. So a lot of times as a leader, I would have to go into command and control mode, and I would have to lower our commitment rates and increase our estimates so that we have time to do learning. And that requires that I actually talk to my management and leadership and actually get that stuff to happen. And that's where the scary part is, because I'm actually asking people here, middle management, to go and say to management, well, things cannot go on this way. So let me give you some ideas on how to actually get that stuff going. But just so you know, this is the model, and all these slides are available in the link that I put in at the beginning of the talk, and you also have a link to it later on. But survival mode, you can detect if you're in survival mode if you don't have any time to learn and slowly practice something. Sending someone to a 3-day course about test-driven development is not the same as learning mode. Learning mode is when that person returns, is that they're allowed to work slowly on the first few tasks. What I mean slowly, it could take 3 to 10 times longer to work on the same tasks for the next month or two as that person learns how to actually adapt to these new practices. You cannot do that in survival mode. In survival mode, the captain doesn't call a meeting, they give orders. But in learning mode, that's where you want to be. That's where you actually want to make that happen. So you have to detect where you are. Second thing is you have to realize that you cannot just get your company and everybody in the company to go to and implement engineering practices immediately. Most big bang transformations, they start, there's focus, then fear sets in, panic, and then abort. Because people are being told to actually implement these practices. And of course, that slows them down considerably. Because they're already in survival mode, they immediately almost abort and say, well, not going to work right now. So it takes a long time, maybe for some teams to emerge successful, but it's a very small number of teams. And there's a lot of pain involved, a lot of money can be lost in there as well. What you want is transformations to be very, very small and incremental in your organization. The recommendation that I have is baby steps or pilots or experiments. And the idea is that each experiment is done in a very, very small and controlled manner to learn from it and then apply it into a slightly bigger group, and then apply the lessons from that into a slightly bigger group. And that is much more possible politically, financially, because the organization needs to be risk averse. And also it's much easier to change the rules for one small team than for hundreds of people in the organization. So what can you start doing tomorrow to actually implement that stuff? Well, the first thing that if you actually you want to start doing these things, but you're in survival mode, you have to start measuring. And a lot of people don't actually implement any type of measurement in their teams. You have to measure so that you can talk to management and convince them that the current situation cannot continue. What do you measure? Well, the basic question you want to ask yourself is, how much does it cost the organization not to implement these practices? Right? How long does it take us, for example, to release something today? How long do people sit there and wait for a build to finish, etc.? What is our quality lagging indicator? Which means, for example, how many production bugs do we find in production that should have been found by our automated pipelines? And then we look at the trend line of that. So I'll give you some examples of metrics that you can use. And again, this stuff is in the slides, and you can also see it in the Miro board that I put the link into. But at the top, what you see here is you have what we call lagging indicators. And the lagging indicators are indicators that are very, very hard to cheat, right? Code coverage is an example of a leading indicator. It's very easy to cheat. Anyone can create more code coverage. But escape bugs found in production is very hard to cheat. You either got them or you didn't. Release frequencies, how many releases you do per year, per week. Lead time is how long does it take from the moment where you think about an idea at the company and that idea actually arriving into a customer on average. It's usually relatively easy to measure because you can track it when it was created, let's say in Jira, up until the moment where it was kind of finalized, it's closed in production, running in production. And then finally, mean time to recover is an example of when we have a production issue, how long does it take to bring the system back up? These are 4 examples of common DevOps related lagging indicators. And you can use them because there are a lot of times there's a lot of associated cost with them. And it's very hard to cheat them. But at the lower level, you have at the team level and the engineering management level, a lot of different techniques, a lot of different, metrics that you can use to measure. For example, you can measure bottlenecks and feedback loops. You can measure how many multiple branches exist today, or when I solve a bug, how many branches do I have to implement it on? How long does it take? Or if I have a build only on a single environment, but I have 50 developers, and on average, how much time does each developer wait for the build to finish every day? Let's say that it's 1 hour, like 10 minutes of times 10. So 1 hour times 50 developers, that's 50 development hours every day on average, times a week, times a month. And you start getting, and then you can calculate a very average cost per developer, an hourly cost. It doesn't really matter what the number is because it's going to end up pretty big. So imagine a $40 per hour or $20 per hour. And then once you get that simple number, say every month we have people waiting for this cost. And it's a few $1,000s, right? How long would it take us to implement, or how long would it take us to get out of this spiral? And of course, you can add more things to that. But the metrics are very important because they translate what you have in your head, your gut feeling, into something that management can actually understand, which is, how does this affect the bottom line? Because in your gut, you know that it affects the bottom line, but you cannot explain it. Measuring is one way of translating. So we have to be good at measuring things because it allows us to communicate things better. The second thing is that once you get permission, you can start experiments and pilots. And experiments and pilots, let me just say that, they can be small. The smaller they are, the more likely you will actually get permission to do them. And you have to use the word experiment because experiment implies this is a temporary thing. We're trying something and we might go back to the way it was, which gives a lot of people, ease of mind to say, okay, it's not going to be that bad. We're not going to change the entire thing. We're just going to try something temporarily and we'll probably go back. Or if it fails, we're going to be okay. So what I put here is something that I, as a consultant, do. The first part here, that's where I'm trying to understand the organization. So you don't usually have to do the first part if you already know the organization. But the parts here, from here to the left to the right, where we're trying to analyze our and choose a strategy of what type of experiment, what are the engineering practices we want to implement. And here we have a set of experiments. And those experiments allow us to find out what is the right thing for our organization. Because I promise you one thing is that no matter what experiment you do, the results for each organization are going to be different, and for each product and the way that you work. So there is no one way to work. So working and doing experiments and trying different tactics of working is the right thing to do. And I think that is what we want as a learning organization, is that we try something and then we try something else. And the one constant that we have is that we keep trying new things. That's what I expect people to do. And then find out what is the methodology that works for your organization, for your team at this time. This is a cone of uncertainty. So when you're trying something, the bigger the cone, the more you're like looking at different avenues, like we should try this one. You're like all over the place. And as time goes by and you try new things, you can focus and you realize some things are better than others. Some things are better than others. And the metrics that you use help you decide if the experiments are actually working. So you start with by measuring things before you do the experiment. You do the experiment, which might take a few weeks, maybe a month or two, worst case scenario. And then you look at the metrics again and you see if something has changed. And that way you know that you're not lying to yourself. And finally, you have to learn how to influence behavior in your organization. You have to understand how people think and work. I recommend looking into the Elastic Leadership Model, and at my blog at 5whys.com, there's also a bunch of reading material that you can look and talk about these influence forces. I do training on that stuff, etc. But I'm not trying to sell that right now. Just realize that learning how people work and how people think is going to make you much more valuable to the organization and allow you to try to make more changes than you thought were possible. So just to summarize, the reasons that we don't actually implement these things are usually lack of time because we are in survival mode. A lot of times as leaders, we are afraid of changing the current state. We think we're stuck in it, so we have to learn how to change that. And a lot of times the organization is stuck in like a culture of efficiency where we're trying to optimize the wrong things, or we just make sure that people are busy, but we're not actually implementing the oil inside the machine. We're just adding more parts to the machine instead of actually oiling it up. And then you don't need all the parts maybe. If you want to get the slides for this, you can go to this link right here. It's go.osherove.com/xpscrum. You can find me on that email address. You can find me on all these websites. Yeah, I really like to collect new domains. And with that, we are finished and we have a few minutes for Q&A. Thank you, everybody. Wonderful. So I'll be joining the Zoom chat. Thank you, everybody. May the force be with you. And remember, fail fast and make it quick. Thanks, everybody.